The goal of this video is to explain and justify how one can quickly and easily do percent changes. So for example, suppose we start with the number 135 and we wish to go up 20%. In order to do this, it's very efficient to take 135 and multiply it by 1.20. Now, the reason you can do this is that 1.20 is 100% plus 20% or 120% written as a decimal. So the decimal of that, of course, is 1.2 or 1.20. So what that means is when we multiply 135 by 1.20, we're actually finding 120% of 135. In other words, we're going to go up 20% from 100%. If we do this calculation directly, we get 162. Now, of course, we can check this by finding that 135 times 0.20 is 27, which we can then add to 135 and get 162 that way. So what this means is we're actually adding first on the percent side as opposed to finding the portion of the 135 and then adding the numbers back up together to get 162. So we'll look at a more complicated problem or two in the next slides. So in this slide, we're going to start with the number 75, and we want to go up 22% from there, and then down 38% from the result of that. So you might think that you have to do this in two separate steps, but in fact, you can simply do 75 times 1.22, which is 122%. In other words, 22% added to the original 100% of 75. And then take that answer and multiply it by 0.62 or 0.62, because if you go down 38% from 100%, you wind up with 62% left. If you do this problem, you can do it one step at a time and get 91.5 for this step, and then multiply by 0.62 and get 56.73. But you really don't need the parentheses or worry about pausing and getting the answer for the first step, because multiplication is commutative and you can do this in any order you wish. So 75 times 1.22 times 0.62 directly gets you 56.73. In fact, you could do 75 times whatever the product of 1.22 and 0.62 is, and you will get the same answer. So 1.22 times 0.62 is 0.7564, and if you multiply that by 75, you will verify that you get 56.73. In the next slide, we'll do a more complicated one yet, and finish with the fourth slide for showing how to find where you started with this method given where you landed. So here's the problem in this slide. We have 86 going up 20%, then from there we'll go up 8.5%, and from there we'll go down 9.1%. Now this is a bit more challenging since we have to worry about the percents that are decimals as well. So it's 86 times 1.20 or 1.2, because that's 20% plus 100% or 120% written as a decimal. Then we're going to go up 8.5%, which is 1.085. So make sure you get the 0 in there. So it's 108.5% written as a decimal. And then we're going to go down 9.1%. So if you go down 9.1% from 100%, you have 90.9%, but you have to write it as a decimal again, so it's 0.909 or 0.909, depending on how you write it. If you multiply all this out, you're going to get an answer, but let's see what this multiplier is in this case. If you multiply that, you get 1.183518. And if you multiply that by 86, you're going to get the answer 101.7825 and some change. Now, one thing to keep in mind here is that you can't simply take 20%, add 8%, call it 28.5%, and then subtract 9.1% and say, oh, I'll just move 86, I'll just move that percent of 86. You can't do that because at each stage you wind up landing on a different number, and when you take 8.5% of that, you're moving a different amount. However, if you use these multipliers, you can do it all in one step. So 1.20 times 1.085 times 0.909 gets you the equivalent effect of multiplying of changing 86 by these percents. What this means is you have 100% of 86 left and 18.3518%. In other words, this is equivalent to increasing 86 by 18.3518%. We'll talk a little bit about that in the next slide. So this is from the second slide, and it was where we started with 75, went up 22%, down 38%, and we wound up at 56.73. Now, the multiplier in this one, as we've shown here, is 0.7564, which means ultimately we found 75.64% of 75. Sorry that the numbers are close, but this is not equivalent to taking 22 minus 38 and saying, oh, we went down 16%. In fact, we went down nearly 25% from our original number. And that's because going down 38% from a bigger number moves you further down. We went up 22% from 75. That doesn't move you as far as 22% from the bigger number. So going down 38% from the big number, the number you land on after going up 22%, is a much bigger drop, and therefore it winds up being a cumulative drop of almost 25%. So here's one more problem. Suppose we start at an unknown place and we went up 10% and then up 35% from that result, and then down 12% from that result, and we finish with 86. Where did we start? Well, we can use the method in the previous slides to simply say x times 1.10 times 1.35 times 0.88 equals 86. That is, we went up 10%, so we multiply by 1.10 or 110%. We went up 35% from there, so we multiply by 1.35 or 135%. And we go down 12%, which means there's 88% of that number left. And so we can do this multiplying. We simply check out what this multiplier is. And so multiplying that, we get 1.1 times 1.35 times 0.88, and that equals 1.3068. And so we know that x times 1.3068 equals 86. We can then divide both sides by 1.3068, and we will get a result, 68. And we can get the result of 86 divided by 1.3068 equaling approximately, of course, since I just picked some random numbers, 65.8096 and some more change. So what that means is if we started at 65.8096, et cetera, we went up 10%, up another 35%, and then down 12%, we would be essentially going up 30.68% from that original number and landing on 86. So we need to go down by dividing by 1.3068. Be careful not to go down 30.68% from 86, because 30.68% of 86 is a bigger drop than if we went up 30.68% from 65.8, because it's a percentage of a larger number.